Hi, in this video I'm looking at this problem here where we've got Ella who's saving for a new car and she's looked at different bank investments and has been offered these three different investment opportunities. One is 5.3% per annum compounding weekly, another is 5.4% per annum compounding daily, and the last is also 5.4% per annum compounding monthly. We want to work out which offer will give Ella the best return. And to do that, we're going to use effective interest rates. So we're going to use our I effective is 1 plus the interest rate divided by how many times it compounds each year to that number minus 1. So we're going to use that rule for all of these offers. So if we have a look at offer 1 and we work out little I and n. So I is 5.3%, but we want to divide that by 100 to get it to be a decimal, so we have 0.053. And n is how many times it compounds each year. We've got compounding weekly, and there are 52 weeks in a year. So now if we go to our rule, I effective for offer 1 is going to be 1 plus little I 0.053 divided by n 52 to the power of n 52 minus 1. And if we put this into our calculator, offer 1's effective interest rate is 0.0544, which if we multiply by 100 to get that as a percentage, it's 5.44%. So that's offer 1. Let's go and have a look at offer 2. So offer 2, we have I this time is 5.4% divided by 100 to get a decimal, so we get 0.054. N, how many times does this one compound? It compounds daily. There are 365 days in 3 out of 4 years. Typically we use 365 days for a year, but if there is a leap year, the bank for that 1 year would calculate it using the extra day with 366. So now let's go to our rule. Our interest rate effective is 1 plus I, which is 0.054, divide by n, 365, to the power of n, 365, minus 1. So for offer 2, putting this into our calculator, our effective interest rate becomes 0.0555 with some rounding in there. As a percentage, this is 5.55%. So offer 2 has 5.55%. Finally, having a look at offer 3. So offer 3, our interest rate is still 5.4%, dividing by 100, giving us 0.054. However, our n this time, offer 3 compounds monthly. So there are 12 months in a year, so this time I'm going to use n as 12. Going to our rule, I effective is 1 plus 0.054 for I, 12 for n, to the power of 12 minus 1. And so offer 3's effective interest rate, if we put that into a calculator, is 0.554, which multiplying by 100 gives us 5.54%. So now we just need to answer the question, and the question was, determine which offer will give Ella the best return. So the best return will come from the investment with the best effective interest rate, which in this case is offer 2, because it is 5.55% compared to either 5.54 or 5.44. So our answer is offer 2 will give Ella the best return as it has the greater effective interest rate. And there we go. We can compare different compounding investments using effective interest rates. We just work them out for each offer we've got and then pick the one that's best, one that's highest. And this is why banks call the effective interest rate their comparison rate, because it enables you to easily compare investments or loans no matter how often they're compounding.